What's up, everyone, and welcome back to All About AI Tech. I'm so hyped to be your guide to the fascinating world of artificial intelligence. Today, we're tackling a topic that's crucial for anyone serious about building powerful AI applications: vector databases. So grab your favorite drink, buckle up, and let's dive into the future of data storage. Before we jump into the cool stuff, let's break down what a vector database actually is. Imagine you have a bunch of images, say photos of different dog breeds. In a traditional database, you might store things like the file name, date, or maybe some basic tags. But a vector database takes things to the next level. It converts those images into multidimensional vectors, which are basically lists of numbers that capture the essence of the image, its features, patterns, you name it. It's like giving each image a unique fingerprint that the computer can understand. So why is this a big deal? Well, these vectors unlock a whole new world of possibilities for AI applications. Think about image recognition. Instead of just searching by keywords, you can now find images that are visually similar to your query. Or take recommendation systems. By analyzing the vectors of products you've liked in the past, these systems can recommend new items you're likely to love. The same goes for semantic search, anomaly detection. The applications are endless. All right, let's meet our first contender, Faiss, developed by the brilliant minds at Facebook AI. Faiss is all about speed and efficiency when it comes to searching for similar vectors. It's like having a supercharged search engine for your AI data. One of its biggest strengths is its GPU acceleration, meaning it can handle massive datasets with lightning-fast processing. If you're working with huge image or video libraries, Faiss is definitely worth checking out. However, it's primarily focused on similarity search, so it might not be the best choice if you need a more versatile database solution. Next up, we have Milvus, an open-source vector database that's been making waves in the AI community. One of the things that sets Milvus apart is its incredible scalability. It can handle billions of vectors without breaking a sweat, making it perfect for large-scale AI applications. Milvus also supports multiple metric types, giving you more flexibility in how you define similarity between vectors. On the downside, setting up Milvus can be a bit more involved, especially if you're not familiar with its architecture. For those who prefer a more hands-off approach, we have Pinecone, a fully managed vector database service. Pinecone takes care of all the infrastructure and maintenance, so you can focus on building your applications without the hassle of server management. It's super easy to use, with a simple API that lets you get started in minutes. The trade-off? Well, being a managed service, it does come with a cost, and you have less control over the underlying hardware. Now, let's talk about Annoy, a C++ library with Python bindings that's known for its speed and simplicity. Annoy is a great choice for applications where you need to find approximate nearest neighbors quickly. It's incredibly lightweight and uses static files, making it very memory efficient. However, keep in mind that Annoy might not be the best fit for massive datasets, as it's primarily designed for in-memory operations. Developed by Google, SCANN is another powerful library specifically designed for finding nearest neighbors in large datasets. It's optimized for performance and integrates seamlessly with TensorFlow, making it a popular choice for deep learning applications. But be warned, setting up and tuning SCANN can be a bit tricky, so it's not the most beginner-friendly option. If you're looking for fast search times and efficient memory usage, HNSW is an excellent open-source library to consider. It constructs a hierarchical graph structure that allows for quick and efficient searches, even in high-dimensional spaces. However, keep in mind that HNSW's performance is tied to the characteristics of the algorithm itself, making it more suitable for specific use cases rather than a general-purpose solution. Verge is a feature-packed, open-source vector search engine that's gaining traction for its user-friendly design. It supports both GraphQL and RESTful APIs, making it easy to integrate with your existing applications. Verge also boasts some cool features like automatic machine learning indexing, which can save you a lot of time and effort. However, running Verge effectively does require some resources, and its configuration can be quite complex. For those who need a good balance between search speed and update speed, Grant might be the perfect fit. This vector search engine is all about maintaining a sweet spot between finding similar vectors quickly and efficiently updating your database with new data. It also supports persistent storage, ensuring your valuable data is always safe and sound. Plus, Grant has excellent documentation, making it relatively easy to get started with. Developed by Yahoo, Vespa is an absolute powerhouse when it comes to handling massive datasets and complex queries. It's highly scalable, supports machine-learned model inference, and comes with a comprehensive set of features. However, Vespa's architecture is quite complex, and there's a steeper learning curve compared to some of the other options on our list. If you're a fan of Kubernetes, then you'll love Vault. This highly scalable distributed vector database is designed to run seamlessly on Kubernetes clusters. It offers automatic indexing and backup features, making it a robust and resilient choice for mission-critical applications. However, deploying Vault does require some knowledge of Kubernetes, which might be a hurdle for some users. Need real-time vector indexing and search capabilities in a distributed environment? VectorFlow has got you covered. This vector database is designed to handle high-velocity data streams and provide near-instantaneous search results. However, keep in mind that VectorFlow is a relatively new player in the field, and its community support might be limited compared to more established options. Let's talk about Gina, an open-source neural search framework that brings the power of AI and deep learning to vector search. Gina allows you to build cloud-native neural search solutions that can handle complex queries and deliver highly relevant results. However, for simpler search tasks, Gina might be overkill, and you'll need some deep learning expertise to leverage its full potential. Now, you might be surprised to see Elasticsearch on this list, as it's primarily known as a search engine. But guess what? With the power of plugins, Elasticsearch can be transformed into a highly capable vector database. It's a solid choice if you're already familiar with Elasticsearch and want to leverage its extensive features and community support. Just keep in mind that using plugins can add some overhead to your system.